Hello everyone, let's go ahead and take a look at our continued studies of statistics. Now what we've started off with is we started off with one variable statistics. And basically what that meant is that we took a look at a particular variable, and based upon its values of that variable, we then looked at the frequency of those particular variable values. Now we also went ahead and took a look at the means of central tendency, measures of spread, etc., etc. And that was how we looked at one particular variable statistics. Now, what we're going to do is we're going to move on now, and we're going to take a look at two variable statistics. Now, just by looking at the difference in the graph, you'll be able to see a very, very big difference between these two. In the one variable statistics, as its name suggests, we only have one variable, but in two variable statistics, we're looking at a variable A and a variable B. So what happens then is that we are now going to be plotting coordinates. And after we go ahead and plot all those coordinates, we then want to go ahead and determine whether or not there's a relationship between the two variables. And that is the primary means by which we go ahead and analyze two variable statistics. So what we're going to take a look at then is what is called correlation. Correlation, as it sounds, is to determine the relationship between two variables, the co-relationship between two variables, shall we say. And basically what correlation does is it quantifies and describes the relationship. Now, there are three basic means by which we can go ahead and describe this relationship: direction, linearity, and strength. When we go ahead and talk about direction, we can talk about the direction as being positive, negative, or none. The linearity means that, okay, if we go ahead and plot all of those points, is it forming a line, or is it forming some other type of function? And lastly, generally when we talk about the direction, we usually talk about the strength as well. So is the strength of the relationship strong, moderate, or weak? Now, those are the three different ways that we can go ahead and describe and quantify correlation. In addition to that, what we want to take a look at as well are outliers. Now, outliers are data which does not follow the overall trend of whatever is plotted here based upon the values of variable A and variable B. We'll take a look at some of those situations in class. Now, the other important thing that we want to go ahead and think about is causation. Because say, for example, if we find that two particular variables are related very strongly, does that mean then that, say for example, the value of variable A causes the value of variable B? Now, being that we're talking about correlation, we're saying that there's a relationship, but that doesn't necessarily mean that we're saying that variable A causes the value of variable B. We're only taking a look at two different particular variables, and therefore we're only considering the relationship between those variables. So just be careful about this idea of causation. Many people might be able to go ahead and think that just because two things are related, therefore there's a cause and effect relationship among those two variables, and that is not the case. Now, let's go ahead and also take a look at some of the various ways that we can take a look at two variable statistics and quantify and describe them based upon those three characteristics. So here we go. What we have here is a plot of two different variables, and these two variables are of course based upon this particular horizontal axis and this particular vertical axis, and assume that those are all the points that we plot. Now, when we go ahead and again think about correlation, because we're talking about two variable statistics, we want to go ahead and talk all about the direction. Now, the direction could be positive, negative, or none. Now, the thing that we're going to do, as opposed to actually determining whether it's positive, negative, or none, I want you to go ahead and think about what you think it is, based upon how I change some of these values. So take a look. Is that positive, negative, or none? Is that positive, negative, or none? Okay? Now hopefully all of you are taking a look at this and considering the slope. Okay? And that would be the right idea. Okay? Now, remember that we also wanted to go ahead and talk about the linearity. Okay? If I was to go ahead and take a look at that scatter plot, would I consider that to be a linear relationship? Or would I consider that to be maybe a different type of function that would then go ahead and describe whether or not there's a relationship between the two? Now notice again, if I go all the way to this part right here, then it definitely seems to be a linear relationship between the points. And again, even if I go down here, there seems to be another linear relationship between the points. Now, being that that's the case, we can then go ahead and talk about the strength of the linearity, and that's what, for now, what we'll limit ourselves to. The strength of the linear relationship and its direction. So, if we go ahead and talk about this linear relationship here, notice that it's a very strong relationship, and notice that it is also going to be negative, because if we were to go ahead and draw that line, it would be a line with a negative slope. Now, of course, as we move this way, as we move this way, then notice that this really doesn't look like there's much of a relationship. It tends to be very scattered, and if we were to go ahead and draw, say for example, a line up as fit, it'd be very difficult for us to actually determine where that line would be. On the other hand, if I continue with this and take a look at that, that looks like a pretty strong relationship. That's even a stronger one. And in this particular case here, it's a strong relationship in the positive direction. Okay, so this particular Wolfram demonstration is called Visualizing Correlations. I suggest and encourage you to go ahead and play with this to actually see all the different types of scatter diagrams that are possible. Now again, what we're doing is we're taking a look at two variable statistics, where we're plotting one variable with respect to the other, and we're looking at describing the correlation based upon its direction and strength. Again, we're going to limit ourselves to lines for this particular section. Again, we want to focus on the direction, strength. And again, remember that there are sometimes going to be outliers, and we'll take a look at some of those situations a little bit later. And remember that thing about causation. It's a very important point. So, play with this visualizing correlation of Wolfram's demonstration, and hopefully that will give you a good sense, visual sense, of how we can go ahead and describe the statistic between two variables. So see you next time in class. Bye-bye.